We're live. Alright, this interior and exterior angle sum notes. It's our first set of notes in Unit 5. Like I said, I mean, it's almost going to feel like an outlier a little bit because after this we're only going to be strictly talking about quadrilaterals, but we kind of just like to teach y'all about all of the polygons first and then we focus in on the quadrilateral. Interior angle sums. So the sum of the degrees of any polygon can be determined by the number of triangles that can be drawn within a polygon. Complete the table below and look at the pattern to find the sum of the degrees in the polygon. As we go through this, you'll kind of start to realize what we're trying to show you. But what it's saying up there is true. It says the sum of the degrees in any polygon can be determined by the number of triangles that can be drawn within a polygon. That's why we focus so much on triangles too. I told y'all we focus a lot of our time in geometry on triangles, but as long as it's a polygon, any shape that's 3 or more sides, we can root it back down to a triangle, any shape. Like all of these shapes y'all see, we can root back down to being a triangle, any of them. And I'll show you what we're talking about. Alright. So the first one, y'all should all know this one is the easy one. Triangle. Probably fill this out without me. Triangle. It says number of sides. Y'all should know. It has 3. The number of triangles you can draw inside of a triangle from that one vertex is going to be 1. It's just a triangle, so it's only going to be 1. And it says the sum of the interior angles. 1. What's the sum of the interior angles of a triangle? This ain't a trick question, huh? What'd you say? Yeah, 180 degrees, man. And you may need a calculator for this. Well, not mine, but you know, your phone. If you don't have one, that'll be fine for right now too. Because I want y'all to see as we go. The second one, this polygon. This is 4 sides, so we call it a quadrilateral. And we just said it has 4 sides. Inside the quadrilateral, going from one vertex, I can draw a diagonal and I can create 2 small triangles inside of that quadrilateral. So the question asks, how many triangles can be created? 2. If that's the case, they want to know the sum of the interior angles of a quadrilateral. If I can create 2 triangles inside of a quadrilateral, what's the total number of degrees I can get inside of a quadrilateral? 360 degrees. The next one, 5 sides is a pentagon. Got 5 sides. We even show you already from one vertex, drawing diagonals in, they were able to create 3 triangles inside of the pentagon. Yes, if you can create 3 triangles, then the sum of the interior degrees, like Reese just said, should be 540 degrees. Keeping it going. The next one is a hexagon. Hexagon has 6 sides. From one vertex in the hexagon, I can draw my lines and create 4 triangles. If I can say it again, 720. And then the pattern starts to show itself to you. Like you don't even need the shape no more. I can just call the shape out to you. The next one is the heptagon. Heptagon has 7 sides. If it has 7 sides, Irvin, how many triangles you assume it's gonna have? Say it again. 4. and 5. Past 5 triangles inside of it, what is the degrees of the triangles add up to? 900. And so on. Y'all just need the names from here. Octagon is next. Eight sides, 6 triangles. So you do 6 times 180. 1080. 1080. Next one is a nonagon. They call this 2 different things. One I use is nonagon though. They call it something else. I can't even remember the name of it right now. One more time. That's 1260. Then decagon. And then we skipping number 11. I don't even know if they have a name for the 11th one. I think they do. We're doing the next one after that, which is the dodecagon. It's called dodecagon. Hold on, let me spell it right. Decagon with a D-O in front of it. Dodecagon, that's 12. 12 sides. So it has 10 triangles. Then the 10 times 180. What you say? We skipped the 11 one. We went to 12. 1800. So the decagon has 1800 degrees inside of it. This was just to help you develop pattern recognition. Like I could ask you about any figure, and once we get up into the numbers, we don't even have. Once we get up into the numbers, we don't even have names for them anymore. We just start calling them by their numbers. Like I don't know if we had one on the front, but on the back, the first one they ask you about is a 15 gun. Like at that point, and then you see they say 18 gun on the other one. That's how it'll look too. So we could ask you about anything. We could ask you about a 22 gun, a 31 gun, whatever. Don't matter. As long as you know the process, you understand how many sides we're talking about and what we're asking you to do. But you got to understand, when you're trying to find the sum of the interior angles, it's not the number of sides, but the number of triangles the figure has that you want to be looking at. That's what you're multiplying 180 by, the number of triangles that is in that figure. And like, Faith, if I ask you about a 22 gun, how many triangles does it have in it? You don't know? That's wrong too. I'm supposed to be the smart kid. Yeah, I said 22 gun. Yeah. Yeah, that's all I want. I just asked how many triangles would it have. I ain't asked for the value. I just asked how many triangles would it have a 22 gun. 20, right? Okay. Faith, I'll try again. A 41 gun. How many triangles is it gonna have? 41 gun. Alright. Alright. So that being the case, it says the sum of the interior angles formula. If n represents the number of sides of a polygon, then the sum of the interior angles can be found by using the formula. And this is the formula you're going to use. So the sum of the interior angles represented by S equals n in parentheses minus 2 times 180. The n minus 2 part is just you getting the number of triangles, if you think about it. Because say if I got a decagon here, 10, I want to do 10 minus 2 to get my 8 number of triangles. Then I'm timesing it by 180. You paying attention, Faith? Alright. This is the formula you want when you're trying to find the sum of interior angles. That's the sum, meaning all of them added together. Now, if I want to find individual angles in a regular polygon, alright, we just talked about this in our definition. Say if we talk about a regular polygon, a polygon that is both equilateral and equal angular. Its center is the point that is equal distance from the vertices. The main part you need to catch is equilateral and equal angular. So if I call a polygon regular, I'm telling you all the sides are the same. I'm telling you all the angles are the same. For example, y'all know this one, so this happens quickly. Like on the first one, the triangle. Say if I call this triangle equilateral, what will y'all tell me all the degrees of the angles were? 60, because y'all just know that all back, because y'all know it has to add up to 180. That's the same thing they ask me about each of these other ones. They're like, okay, for say this was a square, even though it's a rectangle, it's going to give us the same answer. If it was a square, which would be a regular polygon, what would all the degrees of the angles? 90 degrees, right? And so that's because you did 360 probably divided by 4, right? Yeah. Same thing on this one. How would you tell me what each individual angle on this one was if this is a regular pentagon? I can't hear you. I ain't asking you to never. What would you do? No. Come on. Yeah. I just need y'all to understand the concept of it. That being said, so let's write the formula down here. Alright, so therefore it says a regular polygon is one with all sides are equal, therefore all angles are equal. If that's the case, to find the measure of the interior angle in the regular polygon, use this formula. On top is going to be the regular formula, you know, n minus 2 times 180. That's just to get the sum of the interior angles. Then we're going to divide that by n, which is our original number of sides. So you want to divide. So n minus 2 times 180 divided by n. That'll tell you in a regular polygon what each individual angle would be. Alright, the main thing y'all got to catch on these two is when to use this one and when to use the one with the additional piece of divide by the number of sides. So try to figure that out with these two examples on the back. Number 1 says find the sum of the interior angles of a 15-gon. Sum of the interior angles. So in this one, just keep it simple. N minus 2 times 180. And then you got 15 minus 2 times 180. (2,340 degrees). So all of your angles inside of that figure will add up to be that 2,340 degrees. The difference is the next question. The next question asks you what is the measure of each interior angle on an 18 gun. So what is the measure of each interior angle on a regular 18 gun? They're telling you it's a regular, meaning all the sides and angles are congruent. They want to know the measure of each interior angle. For that one, that's when you got to take the step further. So on this one, it's going to be n, minus 2 times 180 divided by n. My n in this case is 18 minus 2 times 180 divided by 18. You already calculated that one, huh? 160 degrees. So that's telling you each individual angle in an 18 gun will be 160 degrees. You need to know the difference from when to use this and when to use this based on what question they're asking you. So that's interior angles. Switching your mind over. I'm doing exterior angles now. This is exterior angle sum. It says exterior angles are always supplementary. Supplementary meaning what, Reese? Dior?
They all equal weighted.
No. Okay. Well, supplementary means 180. Two angles add up to 180. It says exterior angles are always supplementary to the adjacent interior angle. On polygons below, find the measure of each exterior angle along with the sum of all the exterior angles. So, part we need to pick up is they say exterior angles are supplementary to the adjacent interior angle, which is true. If that's the case, then I can easily find my exterior angles here. Looking at the first one, my exterior angle here, they're saying that's supplementary to the adjacent interior angle. So what would this exterior angle here have to be? Wrong. That's not what supplementary means, man. What? Spencer, go ahead, bud. 101 degrees. Well, you said 180 first, so I was worried about that, and I just started not listening to you no more. The next one over here, 40 degrees inside. What's the angle outside have to be? Say it again. 140 degrees. Then this one over here, 61 degrees. What now? 119. Okay. So just by knowing that these are all supplementary, I found all my exterior angles. Add those up. Tell me what you get. They want to know the sum of the exterior angles on the triangle. 360. Okay. Quadrilateral next. Somebody do it, I'll come around to you. Juan, do it so I can come around next to you about this. I just want you to find all the exterior angles first. Uh-huh. 104. Uh-huh. Okay, Juan, what on the quadrilateral, what are the exterior angles add up to? 360 again. Alright. The Pentagon. I'm listening. $98. Okay. 82. So for a pentagon, once again, some of the exterior angles is 360 degrees. Dior, you got hexagon? What's up? A little bit louder, man. A little bit louder. Maybe it's not the best pen to use. Switch. Okay, next. So we took the long way around to do it for a reason, so you can see it. We can prove it to you instead of just telling you. For any polygon, what would the sum of the exterior angles be? 360, no matter what. And we're showing you how right now, so you shouldn't have to question that. You should just know. The reason we're saying that, anytime we start talking about exterior angles, only number y'all should ever be thinking of is 360 on a polygon. When we start talking about exterior angles on a polygon, you should be thinking about 360 and how you can help that, or use that to help you solve or whatnot. Right. And the interior, that's a totally different thing. You've seen the interior is different. There's a whole formula for that. Exterior, you need to be using 360. So practicing with exterior angles, it says, what is the measure of each exterior angle on a regular hexagon? On a regular hexagon, they want to know each exterior angle. Let's talk about the hexagon first, make sure we understand. Hexagon has how many sides? 6, right? Yeah. Hexagon has 6 sides, so how y'all gonna find each exterior angle? I'm just wondering if I gotta tell y'all everything, y'all gonna be able to think and figure something out. No, ma'am. Not at all. It's much simpler than all that. Thank you, bud. 360 divided by 6. I don't know where y'all going with this. Y'all taking a long way around. All you gotta do is 360 divided by the number of sides that you have. We just proved up top that exterior angles are always going to add up to 360. If that's the case, if I know the number of sides I have, I know the number of exterior angles I'm going to have. I ain't got it. I told you ain't got to do no formula for this. Ain't no n minus 2. Ain't none of that. This is exterior angles. I got to understand the difference between the two. If not, you're going to mix them up. The second one, they go in opposite direction. The second one, they say the exterior angle of a regular polygon measures 12 degrees. How many sides does the polygon have? What you said, Reese? How you figure that up? Yeah, 360 divided by 12 degrees, which won't be wrong, but you know I'm going to write a whole equation out for this. So on this one it's straightforward. We just took our number of sides divided by 360. On this one, they want us to find the number of sides, and they want us to they give us the angle that we had to find on this one. So this one we found our angle. This one they give us the angle, and they want us to go in reverse and find the side. So if I was writing an equation, my equation would look like this. 360 divided by my n, my number of sides that I'm trying to find, equals 12 degrees. And then from there I would put 12 over 1, cross multiply and solve. I know I'm going a long way around, but y'all know how I am by now, so you should understand that I was going to do this anyway. 12n equals 360 divided by 12 divided by 12. N equals 30 like Reese said. So the number of sides will be 30. Alright. Last thing, this is important. We'll ask you something like this. It says, given a regular polygon on the coordinate grid, which transformation will place the figure back onto itself? Select all that apply. So on the grid over here, you got a polygon, specifically a hexagon. They want to know which one of those transformations, well, not which one, it says select all that apply, which transformations will land this figure back onto itself. If you look over here, you got to think back to the transformations unit. You should only be seeing reflections and rotations. I don't see no T's, so I know it ain't no translation. It wouldn't make sense for a translation to be there anyway, because if you translate a figure, it's not going to land on itself. It's going to move completely. But they're asking which one of these will land this figure back on itself. And since this figure is kind of lined up in the middle of 0, 0, if I do certain rotations from 0, 0, this figure will spin and land on itself. You just got to figure out which rotations that would be. To figure out a rotation of a figure, the thing you want to do to figure out how a figure rotates, take that figure and divide it by 3, well, the number of sides on that figure divided by 360. This is a hexagon, so if I do 360 divided by 6, this will get 60 degrees. This is telling me every 60 degrees that I rotate, this figure will land on itself. It ain't even just 60 either. It's every 60 degrees that you rotate. So it could be 60, it could be 120, it could be 180. I just keep adding 60 every time. It could be 240, it could be 300, all the way up to 360. And that makes sense. All these are rotations I could do. I divided by 6, so there should be 6 different rotations I could do. And there are 6 different ones. Any of those rotations will land this figure on itself if you rotate it from the center. So specifically, if this was point A, if I rotated 60 degrees, A prime would be here, my new A. If I rotated 120, A double prime would land me up here. but the figure will keep landing on itself every time I spin that 60 degrees. Every 60 degrees, I'll keep landing on that different point in front of each other, my figure. So I'm saying that to say that's how you check for your rotational symmetry on your figure. Then you go over here and check anything that you see. Any of these numbers that you will see over here, you would check. In this case, we only gave you one, which is rotation of 60 degrees. But anything over here that you can see over here, you should check. On the test, it may be more than that. It may be 60. We may put 240 on there. If you don't check 240, then you're wrong. 122 ain't right. Y'all can see that from the numbers that we calculated. The other thing you want to check is the reflection. We said a reflection over the y-axis. Faith. Could we reflect this image over the y-axis and it land on itself? Yeah, you could. So the y-axis right here. If I reflect this image over, it'll land on itself. If you can even see it, the A prime will land over here with A, and then this will go over here. Same as this will go over here, and that will go over there. So it could do a reflection over the y-axis and it'll land on itself. The last, we already said no to this. The last one is reflection over y equals x. Y equals x is the diagonal reflection. I'm bad, I'm just drawing my line in. Draw your diagonal line in and look at it and see if it can reflect over that. You should know where the diagonal line goes. Y'all shouldn't have forgot this is only 2 units ago. I draw my diagonal in at y equals x. Could my image reflect over that and land on itself? I don't hear any guesses. I know. No. So this one's a no too. The only two that were good on this one was the first and the fourth one. Alright. I want to record that other part. Not really. Should have came to school. So the ones I wanted to show you on here, as far as just to help you, because these weren't shown on the notes. Number 4 says the sum of an exterior angle of a polygon is 1,620 degrees. How many sides does the polygon have? This is talking about interior angles though. So it says how many sides does the polygon have. On this one, to figure that out, I will work backwards using the sum of interior angles of a polygon formula, which is the very first one at the top. I'll write out as n minus 2 times 180, and this equals 620. I'm tripping. Had to think about that for a second. 620, which was the sum of my actual angles. Work backwards to solve for n. N is the number of sides. You have to follow the rules of an equation, though. In this situation, we're working backwards. So we're working backwards. We're working in reverse of PEMDAS. We do not do parentheses first. We do everything outside of parentheses first. So working in inverse, we're going to handle it at times 180. Inverse of that would be dividing by 180. Here and here cancels. On this side leaves me with just n minus 2. I can drop it out of the parentheses. On this side, 620 divided by 180, you get 9. And then after that, the last thing you need to do is add 2 on both sides. Cancels here. Yeah. n equals 11. This is how you will work backwards to find the number of sides on that one. I want to start out for yourself because that's just not one I showed you in your notes. Huh? I'm gonna get there. Any questions about that one? Good? No. Let's go. Number 5. Want to do this one? Should be pretty easy for y'all, but I just haven't shown you this directly, so I want to make sure I show you. 5 through 10 says solve to indicate an angle or measure. On this one, they want us to solve for angle x. To solve for that angle, we need to know what the sum of these angles adds up to inside the figure. To figure that out, I need to figure out how many sides my figure have. How many sides does this figure have? 7 sides. So to figure out the sum of the interior angles, I'm gonna do that formula. 7 minus 2 times 180. $900. I guess I'm telling myself. It's 900. Then after that, so now you understand that this figure adds up to 900 degrees here. If that's the case, then you got all your numbers. Just don't forget the 90 degrees. So I start there just so I won't forget it. 90 plus 148 plus 140 plus 136 plus x plus 142 plus 150 equal 900. You need to combine like terms and solve. Everything is a number except for x. So I know it's going to be x plus something. Combine like terms. $806 equals 900. And then once you get to that point, you just subtract the 806. X equals 94. So x equals 94 degrees. You can use that to do number 6, but we're going to do that. You can do that later. I want to get to the ones I need to hit. Let me get you with number 7. Come back. Number 7. And we try to show y'all stuff in all kind of different ways because you can be asked stuff in all kind of different ways. We'll never know exactly how they're going to ask you a question. That's why they throw a lot at you. But we're just trying to make you think at the end of the day. On this one, all they did was give me an expression on one of the angles, which is 10x plus 4. So I gotta think about this for a second. They did also mark all my sides congruent. If they mark all your sides congruent, what are they trying to tell you about that figure? It's equilateral, right? So if it's equilateral, that means it's equal what? Angular. So all the angles are congruent. So I could go through if I wanted to and mark all these little angles congruent in here. Here, 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 here. Even the one on my expression. Here, 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 here. Since I know all the angles are congruent, I can get the value of one of these angles if I use the right formula. You need to use the formula that gives you the sum of, not the sum, the interior angle of the regular polygon. Each interior angle, though. So you want the second one. It's n minus 2 times 180 divided by n. In this case, n would be what? I'm sorry. What's n? How many sides? 4. 10 sides. 10 minus 2 times 180 divided by 10. This will give you what each interior angle will equal. You get it, spit it out. 144, thank you guys. Then from there, so let me talk slow with you. This is telling me that each angle in here is 144 degrees. I can go and write them on all those angles if I wanted to. 144 here, 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 all the way around. I know all these angles are 144 degrees. Even this angle with my expression on it. Since I know all the angles are 144 now, how am I going to solve for x? Wrong. Go ahead, Jamal. What now? That's not my question. I said, how am I going to solve for x? You haven't been here with me long enough, but you need to understand, I never care about the answer, bro. Half the times I don't even solve for the answers. I only care about the setup. Go ahead, Monty. Equals 144. An answer will never help me. Showing me how to solve for an answer will always help me. Yeah, y'all can get it from there. Once again, I really don't care. And once I get to that point, y'all should be good. So number 8, I'm just going to explain number 8 to you. I'm not going to do that. Number 8, they give you a lot of expressions in there, and then they give you some numbers. What you need to know is you need to find the sum of that figure first by doing the sum, the n minus 2 times 180. And whatever you get for that sum, actually we can do that one together. How many sides it got? 6 minus 2 times 180. That should be one of the ones on the sheet. So 720. So when y'all get to write y'all equation, add all this together, set it equal to 720. Y'all can do that on your own later though. Let me do number 9. Ain't even got to do number 9 actually. I just need to talk about number 9 too. Number 9, what kind of angles we got, Juan? This ain't no trick question, Juan. What kind of angles we got? You thinking too hard on this one now. Earl, what kind of angles we got on number 9? Say it one more time. You looking at the right problem? Oh, now you know one. These are exterior angles. They on the outside, Earl. One, what should you know about exterior angles? There you go. You just told yourself how to write the equation. Alright, so number 9, you just need to understand you need to add them up. 7 equals 360. The other ones you should be good on. I was tempted to do number 11 with y'all right now, but I want y'all to try number 11 first. Number 11 is, honestly, I think it's a test question. I don't even think we got a decency to change it. I want to see what y'all going to do first, see if anybody can get it right without me. So, handle your business. We didn't make that bet. I'm good. Because you probably just going to go ask somebody. I'll do it right now. You do it right now.